Okay, SOHCAHTOA, Pythagorean theorem. We're going to use both of those as we're looking now on page 791 in our textbook where we're asked to find trigonometric ratios. And in this example, we are given one of the trigonometric ratios and we're asked to find the remaining five for a given angle. So my advice is when we're dealing with stuff like this, go ahead and put at the top of your page SOHCAHTOA. That kind of gives you a reference point. Now, we're told here that if the tangent of angle B is 3/7, 3/7, find the exact values of the remaining trigonometric functions. Now, a second piece of advice I have is to sketch yourself out a little right triangle. It doesn't have to be perfect. You're just trying to get a reference point here. All right, now, so we know that the tangent is 3/7, and with SOHCAHTOA we know, and we're going to label this as B, this angle right here, B, sloppy B, but hopefully we can get through it. And so that is the opposite over the adjacent, so we've got 3/7 here. And we need to find this side length here. Well, this side length that we're looking to find is opposite the right triangle. And so we'll just, for the moment, we can label that H as for hypotenuse, or C. I did it for C because I'm getting ready to use Pythagorean theorem to find this missing side length. So our Pythagorean theorem is A squared plus B squared equals C squared. So then we've got 3 squared plus 7 squared equals C squared. Let's see, and 3 squared is 9, and 7 squared is 49. Let's see, 9 and 49 is 58 equals C squared. And so C then is going to equal the square root of 58. So this side over here, side length, is the square root of 58. Okay, so now we're ready to find the remaining 5 trigonometric functions. So we're going to start with the sine of B, which is the opposite, so opposite over the hypotenuse. And so that's going to be then 3. 3 is opposite angle B over the square root of 58. Now, you may remember it's bad manners mathematically to leave a square root in the denominator. So we're going to multiply this by the square root of 58 over 58, square root of 58. And that's going to leave us with 3 times the square root of 58 over 58. There's the sine of B. Now let's hit the cosine of B. So the cosine of B is equal to the adjacent over the hypotenuse. And let's see, so our adjacent side to angle B is 7. So we got 7, hypotenuse is the square root of 58. And again, we got a bad manner situation going on here. So we're going to multiply this by the square root of 58 over the square root of 58. And that's going to leave us with 7 times the square root of 58 over 58. Well, there's the cosine. So we got 2 of the 5 done. Now let's see the cosecant. So the cosecant of angle B is the reciprocal of the sine. And the one I want to use is what I originally came up with, because when I flip this over, I'm not going to have a square root in the denominator. So then the cosecant is just simply the square root of 58. That's a 5 over 3. And then the secant of B, well, I'm just going to flip this cosine over. secant of b is now the square root of 58 over 7. And then lastly, we got the cotangent of b, and the cotangent is just the reciprocal of the tangent, and so that's going to equal 7 over 3. All right, well, that's not too bad. We know two side lengths. We got to find the third side. We're going to use the Pythagorean theorem to do that. We're going to let SOHCAHTOA guide us through our 6 trigonometric functions, and shazam, we have done it.